In this video, let's talk about maximum and minimums. A maximum and a minimum occurs on a graph, and we can identify the max and the minimum by these definitions right here. And we're always going to express our maximum and minimum as some kind of ordered pair. So we're going to write these as an x and a y, or an x and an f of x if we're using function notation. The maximum by definition is the point where the graph changes from increasing to decreasing. So in order for a max or a min to occur, you have to have on both these, you have to have a point where you're increasing and then you go decreasing for a max like this. So in a max, your graph starts to increase. And then we get to a point here and it starts to decrease. This is by definition of max. A minimum occurs when the graph changes from decreasing to increasing. So here you're decreasing, and here you get up to an increasing point. So by definition, you have to have something changing, which means that points that you'll see like this right here are not max or mins because there's no changing occurring there. And we can express these through our math notation when we say to go from increasing to decreasing for a max. That means that we're looking at a point from, for instance, if this is the point A and this is the point B. In a max, A is the first point and B is the second point. Do we see that? So we could write that like this. You would have the point A, f of A. This is a point function notation. And this is the point B, f of B in function notation. And so in a maximum, look what happens. The y value here, our f of A, is lower than the second y value here at f of B. So by definition, we can write a max as from a point changing from increasing to decreasing, or when f of A is less than, which means it's lower than f of B, or the first point is lower than the second point. For a minimum, again, using that same notation, then you can see that if this is the first point right here, and then we go to this point, we get to this point now, we see that again, if we're calling those points A and B, this time f of A will be greater than f of B. So the first y value, we're going to say, let's start here, this y value is greater than this y value. That's what this is saying. And when we do this, then we're always going to express it as ordered pairs, and we're looking for points where they're changing. So there's two types of maximum and minimums you can look at. If a value is the absolute highest value on the graph, it's the absolute highest or the absolute lowest value on the graph, that means there's no points that are higher or lower than that graph. We call it an absolute. We call it absolute. So the word absolute means this is the highest or lowest value on the entire graph. And it has to be, we're going to call it absolute maximum minimum. So it has to be a highest or lowest changing point on the graph. And you can only have one of those. You can only have one absolute on the graph. The other value that it can be, and what you'll see a whole bunch of changing points on the graph, but they're not the highest or lowest. If you see that, that means that you're dealing with what we call a relative or a local. The word local means that it's a maximum or minimum at that point, but it's not the highest or the lowest. So we're going to look at these terms here, and local and relative mean the exact same thing. So let's look at these graphs and try to look at the identified maximum and minimums and tell you what kind of they are. So the first thing is, if we look here at these points, I'm going to circle all of the maximums on this graph. So here's a max, here's a max, here's a max. Those are all maximums because at those particular points they started by increasing, and when they get to those points, they start to decrease. So they're changing their direction at all these points. Now, this type of max is not the highest. This first one is not the highest max on the graph. So this is going to be a local max or a relative max. This graph over here, this max right here is also not the highest. So we're going to call this also a local max. Now, This particular point, though, it is the highest. And there's no other point around, or there's no other point that is higher than it. So this is called the absolute max. Likewise, this point is changing direction. This point is also changing direction. Because of these arrows right here, that tells me that there are points on both sides of these points that are always going to be lower than them. And because of that, we don't have an absolute local. We don't have an absolute min. We only have local mins here. So this is local, and this is also local. Now that we've identified what kind of things they are, and this is let me write what they are: local min, local max, absolute max, local max. Now that we've identified what they are, let's go ahead and actually find the values. So there's two types of questions you can ask about max and mins. The first thing you can ask is, where does the max occur? The second thing you can ask is, what is the max value? So if you look at this first one, the max occurs at the x value. The max will occur at the x value for all of these. So here I'm occurring at -1, -2, -3, -4, -5. So the point here is the point -5 for is where it's occurring at. The actual local max value, or the max value here, is the point on the y now, that's the 1. So -5, 1. Here, your local max occurs at 0. The absolute max occurs at 0, and the actual value is going to be 1, 2, +3. Here, the local max occurs at 4, and the actual value for the local max is 1. Local min occurs at -3, and the actual value of the local min is -2. And here, the local min occurs at 2. The actual value, though, for the local min is the y value of 0. And again, we can express these as using the function notation. For instance, this local min, you would write it as f of -3 equals -2. That's using function notation. So you can express all of these points just like that by replacing the x and f of x equals the y value. Look at the last graph and talk about how this one's a little bit different. So again, we're looking for points where they're changing first. So it's changing here and here, and it's also changing here. And we can see that this one these are going to be minimums. That's a minimum, and that's a minimum. Identifying the types of minimums that they are, though, this is going to be notice there are no points lower than this except this point, but they're a tie. They're at the same spot. Because they are a tie, you can only have one absolute. These are both going to be called what we call local mins, or relative mins. This point right here, we know it's a max. It's going from increasing to decreasing. So it's changing direction. But notice that there are always going to be points higher than it. And because there's always points higher than this is going to be a local max. So when we look at this now, then, the local max is occurring at the value of 0, 3. And the local mins occur. One occurs at -2, 0. The other one occurs at +2, 0.